Stream dürfte jetzt an der Stelle live sein. Die Keynote dürfte auch jeden Moment losgehen. Aber bevor es soweit ist, ja, gibt es jetzt erstmal ein Wort vom heutigen Sponsor und das ist VIP-cdkdeals. Bei VIP-cdkdeals findet ihr offizielle Microsoft-Keys, ob Windows 10 oder 11, Microsoft Office, Games auf sämtlichen Plattformen wie Steam, Origin und Uplay zu wirklich guten Preisen. Gerade bei Windows 11 sind die Preise wirklich gut, also wenn du gerade einen neuen PC baust oder einfach einen günstigen Windows-Key suchst, dann findest du den Link natürlich in der Infobox. Inzwischen ist der Preisunterschied zwischen Windows 10 oder 11 nicht mehr so groß, weswegen ich mir einfach das neuere Betriebssystem holen würde. Ich habe das Ganze bereits mehrfach ausprobiert, die Aktivierung läuft reibungslos und inzwischen habe ich Windows 11 auf meinem Laptop als auch meinem PC zu Hause installiert. Mit meinem Rabattcode GU25 erhaltet ihr aktuell 30% Rabatt, also anstelle von den schon enorm günstigen 28 €, zahlt ihr am Ende glatte 20 € für den Windows 11 Key. Ich bin sehr zufrieden und bei VIP-cdkdeals macht ihr echt einen Schnäppchen. Nachdem ihr euren neuen Windows Key erhalten habt, gebt ihr das Ganze über den Windows-Aktivierungsassistenten ein, drückt auf Aktivieren und los geht's. Ihr könnt sehen, die Windows-Lizenz ist aktiviert. Mehr Infos und Links dazu findet ihr unten in der Videobeschreibung. So, Freunde, wir haben es pünktlich geschafft. Ja, die Keynote ist noch nicht durchgestartet. Ich mache einmal ganz kurz den Refresher. Ja, wir sehen es. Es gibt noch einen kleinen Wartebildschirm, bevor Jensen Huang höchstpersönlich hier auf die Bühne tritt. Und ich habe jetzt erstmal den Hintergrund ein bisschen gemutet, damit wir hier nicht diese Elevator-Music im Vordergrund vom Stream haben. Und dann können wir auch direkt erstmal zusammen einen kleinen Soundcheck machen, oder? Also, ja, ihr seht es hier an der Stelle. Die Keynote ist noch nicht losgegangen, wir sind pünktlich. Es war wirklich gerade ein kleiner Wettkampf, ja, ein Wettrennen gegen die Zeit. Ich habe nämlich aktuell ein Video gerendert, geschnitten davor und das kommt heute noch online, also nach dem Stream. Ich denke, ja, wie spät haben wir es? 18 Uhr. Gegen 19, 20 Uhr wird es ein mega krasses Video geben. Also macht euch da schon mal auf jeden Fall drauf gefasst. Ich habe Intels Microcode getestet, Intel Arrow Lake, ja, den 285K, gegen den Ryzen 9800 X3D getestet, aktuelle Games. Und ja, da bin ich auch zu wirklich sehr, sehr spannenden Schlüssen gekommen. Oh mein Gott. Ja, und ich denke, es dürfte den einen oder anderen von euch interessieren. Gerade wenn es jetzt um so eine aktuelle Entscheidung geht, ja, für welches Produkt würde ich jetzt meine Empfehlung aussprechen. Und vor allem jeder, der ein Arrow Lake-System hat, ja, ich habe so ein bisschen die Lösung, ja, woran es liegen könnte und wie man die Performance anziehen kann. So, ja, das kommt auf jeden Fall heute online, wird ein spannendes Video. Und ich bin mir dessen bewusst, ja, wenn wir uns hier ganz kurz im Community-Bereich hier die Beiträge anschauen, dann habe ich gestern eine Umfrage gestartet zu dem heutigen Livestream, ja, wer alles Bock hätte, heute dabei zu sein. Und ja, 70% haben gesagt nein. Ich habe mich trotzdem dafür entschieden, hier das Event gemeinsam mit euch zu schauen und dementsprechend, ja, hoffe ich, dass es sich lohnen wird, weil meine Vermutung ist, ja, wie die letzten 2 Jahre oder eigentlich seit jeher, wenn wir uns mal anschauen, ich habe sie zwar immer gestreamt, die GTC, aber es gab nie wirklich was Großes. Wow, vor 6 Jahren, 2018, no way. Also das ist wirklich ein Oldschool-Video von mir. Aber die GTC vor einem Jahr und 2023 und 2024, da gab es halt eher viel Gerede rund um das Thema AI und das wird heute wahrscheinlich auch nicht anders sein. Ja? Aber Nvidia macht gerade wirklich eine Zeit durch, also gerade im Gaming-Bereich und ich bin wirklich sehr, sehr gespannt darauf zu sehen, was wir hier präsentiert bekommen, weil ja, das ganze Thema bringt natürlich auch viel Geld mit, ja, auf die Bühne. Ich refresh hier nochmal ganz kurz. Announcement, Score More Content. Also wir checken hier nochmal ganz kurz rein. Watch Now. Okay, das ist auch direkt einfach verlinkt sozusagen zu dem Stream, den ich gerade hier geöffnet habe. Ja, das heißt, den lassen wir jetzt auch einfach offen. Und ja, ich bin wirklich sehr, sehr gespannt. Sobald hier der erste von euch mit im Chat sein sollte, lasst mich das gerne einmal ganz kurz wissen. Also gerade was auch den Ton angeht, das Bild angeht. Ich habe nämlich mich dazu entschlossen, heute diesen Stream überhaupt zu machen, weil ich so einen kleinen Testdurchlauf haben wollte, ja, mit ein paar Settings. Denn ja, im April wird es richtig krass abgehen. Also Ende des Monats, am 29.03. ist die Jahr von Meta. Also auch dort, gerade wer im Bereich Augmented Reality mit der Orion gespannt auf Neues von Meta ist, da wird es ein eigenes Event zu geben, neben der sonst immer abgehaltenen Meta Connect. Die ist erst im September, Ende des Jahres, aber die Jahr 2025 sozusagen als eigenes Event für KI-Produkte mit Jahr 4 wird auf jeden Fall von mir live gestreamt am 29. und dann darauf folgend. Leute, ein Event nach dem anderen. Am 1.4. ist die Intel Vision 2025. Ist auch sehr, sehr spannend, weil, ja, Panther Lake 18a wird auf 2026 verschoben. Was kommt dieses Jahr? Also ein Arrow Lake Refresh wird gemunkelt. Und wir wissen jetzt, seit etwa einer Woche gibt es einen neuen CEO. Und da macht sich Nvidia hier bereit, ihren CEO ins Rennen zu schicken. Es geht los. Die GTC 2025 im März. Let's go. Ich bin gespannt. Genießen wir jetzt erstmal das Event.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI.
Wir alle lieben Tokens.
Tokens have opened a new frontier. The first step into an extraordinary world, where endless possibilities are born. Tokens transform images into scientific data, charting alien atmospheres and guiding the explorers of tomorrow. They turn raw data into foresight. So next time, we'll be ready. Tokens decode the laws of physics to get us there faster. And take us further. Tokens see disease before it takes hold. They help us unravel the language of life and learn what makes us tick.
Also sie haben es diesmal auf jeden Fall gut mit der Musik gemeint.
Tokens connect the dots, so we can protect our most noble creatures. They turn potential into plenty. And help us harvest our bounty. Tokens don't just teach robots how to move, but to bring joy.
Einfach Ernteroboter. Das war krass, die Drohnen.
To lend us a hand.
AI-Drohnen, die Äpfel pflücken.
And put life within reach. Together, we take the next great leap to bravely go where no one has gone before.
Gänsehautmoment. Also, ja, Holz von Obi sagt, wann ist Cyberpunk dran? Und Nick sagt Servus, ich grüße euch beide. Und alle anderen natürlich auch, die im Chat sind. Beziehungsweise gerade zuschauen. Let's go, Nvidia. Woo. Was für ein Einstieg. Nice, jedes Mal.
Nvidia Founder and CEO Jensen Huang.
Wirklich, also die GTC ist von Jahr zu Jahr imposanter und ich bin gespannt, was der gute Jensen jetzt zu bieten hat. Wow, er hat seine Er hat seine Oldschool-Lederjacke rausgeholt.
What an amazing year. We wanted to do this at Nvidia. So through the magic of artificial intelligence, we're going to bring you to Nvidia's headquarters. I think I'm bringing you to Nvidia's headquarters. What do you think? This is where we work. This is where we work. What an amazing year it was, and we have a lot of incredible things to talk about. And I just want you to know that I'm up here without a net. There are no scripts, there's no teleprompter, and I've got a lot of things to cover, so let's get started.
Wow.
First of all, I want to thank all of the sponsors, all the amazing people who are part of this conference. Just about every single industry is represented. Healthcare is here, transportation, retail, gosh, the computer industry. Everybody in the computer industry is here. And so it's really, really terrific to see all of you, and thank you for sponsoring it. GTC started with GeForce. It all started with GeForce. And today, I have here a GeForce 5090. And 5090, unbelievably, 25 years later, 25 years after we started working on GeForce, GeForce is sold out all over the world. This is the 5090, the Blackwell generation, and comparing it to the 4090, look how it's 30% smaller in volume. It's 30% better at dissipating energy and incredible performance. Hard to even compare, and the reason for that is because of artificial intelligence. GeForce brought CUDA to the world. CUDA enabled AI, and AI has now come back to revolutionize computer graphics. What you're looking at is real-time computer graphics, 100% path traced. For every pixel that's rendered, artificial intelligence predicts the other 15. Think about this for a second. For every pixel that we mathematically rendered, artificial intelligence inferred the other 15. And it has to do so
ja, also die Preisgestaltung der 5000er ist schwierig. Schwierig zu rechtfertigen.
From frame to frame to frame, going forward or backwards because it's computer graphics, it has to stay temporally stable. Incredible. Artificial intelligence has made extraordinary progress. It has only been 10 years. Now, we've been talking about AI for a little longer than that. But AI really came into the world's consciousness about a decade ago. Started with perception AI, computer vision, speech recognition, then generative AI. The last 5 years, we've largely focused on generative AI, teaching an AI how to translate from one modality to another modality, text to image, image to text to video, amino acids to proteins, properties to chemicals, all kinds of different ways that we can use AI to generate content. Generative AI fundamentally changed how computing is done. From a retrieval computing model, we now have a generative computing model.
Ich finde es wirklich cool, dass er komplett ohne Teleprompter die Präsentation sozusagen frei rausmacht. Ja, das macht es natürlicher und das braucht Nvidia gerade. Ja, weg von AI-Präsentationen mit komplett geskripteten Texten.
AI understands
Jensen
context
Ich hoffe, er hat heute was für uns dabei, ja, was auch vielleicht so ein bisschen uns positiv stimmen kann. Ja? Nicht nur eine 5090, die keiner kaufen kann.
Rather than retrieving data, it now generates answers. Fundamentally changed how computing is done. Every single layer of computing has been transformed. The last several years, the last couple of 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about
die 5080 Ti, die kommt deutlich später, Leute. Deutlich später.
And it can plan in action. It can plan and take action. It can use tools because it now understands multimodality information. It can go to a website and look at the format of the website.
Aber das wäre krass. Das wäre krass, wenn sie jetzt einfach schon die TI raushauen würden. Ich meine, machen könnten sie es. Einen Unterschied würde es nicht machen.
Agentic AI. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next
ja, eine 5060, da hätte ich auch Bock drauf. Also
which has been enabled by physical AI.
Energiesparsam und leistungsstark.
The physical world. It understands things like friction and inertia,
und
cause and effect.
Vor allem preisgünstig.
Object permanence. When some corner doesn't mean it's disappeared from this universe. It's still there, just not seeable. And so that ability to understand the physical world, the three-dimensional world, is what's going to enable a new era of AI, we call physical AI, and it's going to enable robotics.
Neomatrix sagt, die Nachfrage der jetzigen Karten. Die Frage ist, haben wir sie nicht schon seit mehreren Wochen gedeckt eigentlich? Also, die Leute kaufen, und das werden sie bis zum Ende der Generation richtig gedeckt werden, wird sie nicht.
Is we're going to have to grow San Jose, and we're working on it. We got a lot of land to work with. We got to grow San Jose. So that we can make GTC look. I have to just, as I'm standing here, I wish all of you could see what I see. And we're in the middle of a stadium. And last year was the first year back that we did this live. And it was like a rock concert. And it was described, GTC was described as the Woodstock of AI. And this year, it's described as the Super Bowl of AI. The only difference is everybody wins at this Super Bowl. Everybody's a winner. And so every single year,
if you buy more
people come,
you get more.
AI is able to solve more interesting problems for more industries and more companies. And this year, we're going to talk a lot about agentic AI
oh ja,
and physical
bei der
AI.
5060 habe ich sehr hohe Hoffnungen für den Small Form Factor und RTX-Systeme.
In each phase of AI, 3 fundamental matters are involved. The first is how do you solve the data problem? And the reason why that's important is because AI is a data-driven computer science approach. It needs data to learn from. It needs digital experience to learn from. To learn knowledge and to gain digital experience. How do you solve the data problem? The second is how do you solve the training problem without human in the loop? The reason why human in the loop is fundamentally challenging is because we only have so much time, and we would like an AI to be able to learn at superhuman rates, at super real-time rates, and to be able to learn at a scale that no humans can keep up with. And so the second question is, how do you train the model? And the third is, how do you scale? How do you find an algorithm whereby the more resource you provide, whatever the resource is, the smarter the AI becomes? The scaling law. Well, this last year, this is where almost the entire world got it wrong. the computation requirement, the scaling law of AI is more resilient and in fact, hyper-accelerated. The amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. And let's reason about why that's true. The first part is let's just go from what the AI can do. Let me work backwards. Agentic AI, as I mentioned, at its foundation is reasoning. We now have AIs that can reason, which is fundamentally about breaking a problem down step by step.
Also Jensen verstrickt sich wieder in seine AI-Verschwörungstheorie.
In a few different ways and selects the best answer. Maybe it solves the same problem in a variety of ways.
Okay, ich mute mal ganz kurz Jensen. Wenn gleich was Gravierendes kommt, werde ich direkt zurückswitchen. Ich höre ihn die ganze Zeit lang, aber zu dem Punkt, ne, dass viele sich jetzt aktuell gerne eine Grafikkarte kaufen würden und diese halt im Moment zu teuer sind, das verstehe ich. Ne? Das Problem ist, es ist keine konkrete Bewegung irgendwie von den Boardpartnern, wo jetzt beschlossen wurde, da jetzt deutlich mehr zu verlangen, sondern was hier wirklich am Ende des Tages, das ist, womit wir eigentlich alle gerechnet haben, waren die Sanktionen und die USA-China-Tariffs. Ja, die sind jetzt wirklich erst überhaupt zum Einsatz gekommen. Also wir merken jetzt erst die Anfänge, wirklich die Anfänge von den Auswirkungen. Die Nachfrage ist hoch, weil die Leute natürlich die neuen Generationen erwartet haben, aber es sind nicht viele Produkte gewesen per se. Egal ob jetzt Nvidia oder AMD. AMD hat das Ganze natürlich vom Scaling her ein deutlich günstigeres Produkt produziert. Ja? Also ein Produkt, das auf alten Arbeitsspeicher setzt. GDDR6 versus GDDR7. So, und das Ungleichgewicht, Nvidia hat noch zudem gewusst, okay, sie produzieren jetzt eine 5000er-Generation, die aber im Endeffekt nur ein Refresh der 4000er ist, weil das muss man bedenken. Blackwell hat jetzt keinen anderen Fertigungsprozess in dem Sinne, es ist halt eine verbesserte Architektur, aber das, was der Hauptgrund ist, dass kaum 5000er-Karten da sind, die da sind, gescalpt wurden und zu überteuerten Preisen den Markt einfach komplett aus den Fugen geworfen haben und dann AMD hinterhergeschoben hat und natürlich ein Produkt platziert hat, wo die Nachfrage schon künstlich aufgepusht wurde. Und jetzt sehen wir erst, nachdem sich die Preise und die Nachfrage so ein bisschen gedeckt hat, langfristig gesehen, durch diese Sanktionen, durch diese Inflation, die da herrscht sozusagen auf dem Markt, die tatsächlichen Preise, die uns jetzt auch in nächster Zeit definitiv begleiten werden und nicht nur auf Seiten der GPUs. Wenn ihr euch die CPUs anschaut, klar, der 9800 X3D ist jetzt kein Messwert, weil der ist einfach schon 100, 200 Euro abseits der UVP gelaufen. Aber ich versichere es euch, egal welcher Bereich, egal ob Hardware oder in anderen Industriesparten, Preise und Verfügbarkeiten, das sind einfach reale Probleme, mit denen wir dann zukünftig zu kämpfen haben, neben schon wirtschaftlich schweren und angespannten Situationen. So, und ich würde immer sagen, ja, egal welche Grafikkarte, egal welcher Zeitpunkt, die Karte, die man sich zum jetzigen Zeitpunkt leisten kann, ist die richtige für einen, ohne jetzt abgehoben zu klingen, natürlich immer in einem vernünftigen Verhältnis, in einem Maßstab, ja. Also nicht im Sinne von, ich kann mir eine 5090 kaufen, das ist die GPU für mich. Keiner sollte sich eine 5090 für Gaming holen. Just saying. Also, jetzt hören wir wieder schön gebannt dem Jensen zu. Ich hab Bock drauf.
Basically reinforcement learning of an AI as it attacks or tries to engage solving a problem step by step.
Hat er gerade gesagt, AIs greifen uns an?
We have many problems that have been solved in the history of humanity where we know the answer.
Er hat es gesagt.
We know the equation of a quadratic equation, how to solve that. We know how to solve a Pythagorean theorem.
Naja, Fred, du sagst, wenn du jetzt dringend eine Karte brauchst, es gibt nicht viele Alternativen als die du jetzt genannt hast. Lieber was Günstiges übergangsweise holen und dann in einem Jahr vielleicht richtig rein investieren. Das macht dann mehr Sinn. Weil aktuell gibt es kaum etwas, was gut verfügbar und vor allem preislich gut gelistet ist.
Those kind of problems, on and on and on, we have hundreds of these problem spaces where we can generate millions of different examples.
Das stimmt, GTA 6 wird
and give
viel
the AI
Impact haben.
hundreds of chances to solve it step by step as we use reinforcement learning to reward it as it does a better and better job. So as a result, you take hundreds of different topics, millions of different examples, hundreds of different tries, each one of the tries generating tens of thousands of tokens. You put that all together, we're talking about trillions and trillions of tokens in order to train that model. And now with reinforcement learning, we have the ability to generate an enormous amount of tokens.
Also wir sehen, AI, Artificial Intelligence und Machine Learning ist noch schwieriger, noch komplexer geworden. Ja? Und Nvidia hat die Lösung. Gleich kommt der Sales Pitch. Gleich kommt die neue GPU.
And you can see that the industry is responding. This is, what I'm about to show you is Hopper shipments of the top 4 CSPs. The top 4 CSPs. They're the ones with the public clouds. Amazon, Azure, GCP, and OCI. The top four CSPs, not the AI companies, that's not included, not all the startups, not included, not enterprise, not included, a whole bunch of things not included, just those 4. Just to give you a sense of comparing the peak year of Hopper and the first year of Blackwell, okay? The peak year of Hopper and the first year of Blackwell. So you can kind of see that, in fact, AI is going through an inflection point.
Also Neo, da bin ich komplett bei dir. Also ich sag's so, ne, ich habe mir eine 4070 Ti super geholt für knapp 800 €. Das hat wehgetan, aber jetzt gibt es keine mehr. Also, ja.
It says a lot of people are using it with great effect. And the amount of computation necessary to train those models.
Und man weiß halt auch nicht, was in einem Jahr ist. Ne, man sollte immer gerade im Gaming-Bereich den Moment, sage ich mal, leben, ja, und genießen, was man halt jetzt geboten bekommt. Und ja, zumindest jetzt ist die Zukunft ungewiss.
Across the board. We're now seeing, and this is, the purple is the forecast of analysts about the increase of capital expense of the world's data centers, including CSPs and enterprise and so on, the world's data centers through the end of the decade, so 2030. I've said before that I expect data center build out to reach $1 trillion, and I am fairly certain we're going to reach that very soon. 2 dynamics is happening at the same time.
Sehr wichtig für die Investoren. Hat jemand $1 Trillion gesagt?
The vast majority of that growth is likely to be accelerated. Meaning, we've known for some time that general purpose computing has run its course, and that we need a new computing approach. And the world is going through a platform shift from hand-coded software running on general purpose computers to machine learning software running on accelerators and GPUs. This way of doing computation is at this point past this tipping point. And we are now seeing the inflection point happening, the inflection happening in the world's data center build-outs. So the first thing is a transition in the way we do computing. Second is an increase in recognition that the future of software requires capital investment. Now, this is a very big idea. Whereas in the past, we wrote the software and we ran it on computers, in the future, the computer is going to generate the tokens for the software. And so the computer has become a generator of tokens, not a retrieval of files. From retrieval-based computing to generative-based computing, from the old way of doing data centers to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one job only, generating these incredible tokens that we then reconstitute into music, into words, into videos, into research, into chemicals or proteins. We reconstitute it into all kinds of information of different types. So the world is going through a transition in not just the amount of data centers that will be built, but also how it's built.
Aber
Well,
ist das
everything in the
Ziel?
data center will be accelerated. Not all of it's AI. And I want to say a few words
Ich
about
hoffe
this.
nicht.
You know, this slide is genuinely my favorite. And the reason
Nvidia
for that
erhofft
is
sich das
because
natürlich,
for
ne,
all of
weil
you coming to GTC,
Big Cash.
all of these years, you've been listening to me talk about these libraries this whole time. This is in fact what GTC is all about, this one slide. And in fact, a long time ago, 20 years ago, this is the only slide we had. One library after another library after another library. You can't just accelerate software, just as we needed an AI framework in order to create AIs, and we accelerate the AI frameworks. You need frameworks for physics and biology and multi-physics and all kinds of different quantum physics. You need all kinds of libraries and
Übrigens nice, dass ihr alle so zahlreich eingeschaltet habt, obwohl das Ganze sehr spontan von meiner Seite aus war. Also pusht gerne die Däumchen nach oben.
This first one
Würde mich
is
freuen.
incredible. This is CuPy numeric. NumPy is the #1 most downloaded Python library, most used Python library in the world. Downloaded 400 million times this last year. cuLitho is and CuPy numeric is a zero change drop-in acceleration for NumPy. So if any of you are using NumPy out there, give CuPy numeric a try. You're going to love it. cuLitho, a computational lithography library. Over the course of 4 years, we've now taken the entire process of processing lithography, computational lithography, which is the second factory in a fab. There's the factory that manufactures the wafers, and then there's the factory that manufactures the information to manufacture the wafers. Every industry, every company that has factories will have 2 factories in the future. The factory for what they build and the factory for the mathematics. The factory for the AI. Factory for cars, factory for AIs for the cars. Factory for smart speakers and factories for AI for the smart speakers. And so cuLitho is our computational lithography, TSMC, Samsung, ASML, our partners Synopsys, Mentor, incredible support all over. I think that this is now at its tipping point. In another 5 years' time, every mask, every single lithography will be processed on NVIDIA CUDA. Ariel is our library for 5G, turning a GPU into a 5G radio. Why not? Signal processing is something we do incredibly well. Once we do that, we can layer on top of it AI for RAM, or what we call AI RAM, the next generation of
Also es sind hier wirklich viele Topics und viel zukunftsweisende Konzepte, beziehungsweise ja, schon die tatsächlich umgesetzt wird von Nvidia.
Because there's only so much information spectrum we can get, not if we add AI to it. Co-opt,
Nice, Fred, ich freue mich, dass du meinen Stream der Musik vorgezogen hast. Ich freue mich, dass du dabei bist und alle anderen natürlich auch. Mega nice.
Seats and flights, inventory and customers.
Nach dem Stream muss ich auch kommen.
Workers and plants, drivers and riders, so on and so forth, where we have multiple constraints, a whole bunch of variables, and you're optimizing for time.
Gute Frage, ist es Kunstleder oder nicht?
Quality of service, usage of resource, whatever happens to be. Nvidia
Ich glaube, so viele Jahre, wie er sie trägt, ist es kein Kunstleder. Aber zur CES hatte er doch eine Jacke mit so Krokodillederoptik, oder? Die hat er jetzt abgelegt. Also.
Almost everybody is using either Gurobi or IBM Cplex or FICO. We're working with all 3 of them. The industry is so excited. We're about to accelerate the living daylights out of that industry. Parabricks for gene sequencing and gene analysis. Monai is the world's leading medical imaging library. Earth-2 multi-physics for predicting in very high resolution local weather. Quantum and CUDA Q. We're going to have our first quantum day here at GTC. We're working with just about everybody in the ecosystem, either helping them research on quantum architectures, quantum algorithms, or in building a classical accelerated quantum heterogeneous architecture. And so really exciting work there. Q equivariance and Q tensor for tensor contraction, quantum chemistry. Of course, this stack is world famous. People think that there's one piece of software called CUDA, but in fact, on top of CUDA is a whole bunch of libraries that's integrated into all different parts of the ecosystem and software and infrastructure in order to make AI possible. I've got a new one here to announce today. QDSS, our sparse solvers, really important for CAE. This is one of the biggest things that has happened in the last year. Working with Cadence and Synopsys and Ansys and Dassault and all of the systems companies, we've now made possible just about every important EDA and CAE library to be accelerated. What's amazing is until recently, Nvidia's been using general purpose computers running software super slowly to design accelerated computers for everybody else. And the reason for that is because we never had that software, that body of software optimized for CUDA until recently. And so now our entire industry is going to get supercharged as we move to accelerated computing. QDF, a data frame for structured data. We now have a drop-in acceleration for Spark and drop-in acceleration for Pandas. Incredible. And then we have Warp, a library for physics that runs in a Python library for physics for CUDA. We have a big announcement there. I'll save it in just a second. This
Wer weiß, ob es tatsächlich Jensen ist und er nicht vielleicht AI generiert ist. Das ist die Frage.
Accelerated computing. It's not just CUDA. We're so proud of CUDA. But if not for CUDA and the fact that we have such a large installed base, none of these libraries would be useful for any of the developers who use them. For all the developers that use them, you use it because, one, it's going to give you incredible speed up. It's going to give you incredible scale up. And two, because the install base of CUDA is now everywhere. It's in every cloud, it's in every data center, it's available from every computer company in the world, it's literally everywhere. And therefore, by using one of these libraries, your software, your amazing software can reach everyone. And so we've now reached the tipping point of accelerated computing. CUDA has made it possible. And all of you, this is what GTC is about, the ecosystem. All of you made this possible. And so we made a little short video for you. Thank you.
All right.
To the creators, the pioneers, the builders of the future, CUDA was made for you. Since 2006, 6 million developers in over 200 countries have used CUDA and transformed computing. With over 900 CUDA-X libraries and AI models, you're accelerating science, reshaping industries, and giving machines the power to see, learn, and reason. Now, Nvidia Blackwell is 50,000 times faster than the first CUDA GPU. These orders of magnitude gains in speed and scale are closing the gap between simulation and real-time digital twins. And for you, this is still just the beginning. We can't wait to see what you do next.
Wow.
I love what we do. I love even more what you do with it. And one of the things that most touch me, in my 33 years doing this, one scientist said to me, Jensen, because of your work, I can do my life's work in my lifetime. And boy, if that doesn't touch you, well, you got to be a corpse. So this is all about you guys. Thank you. All right, so we're going to talk about AI.
Zyklen
But you know,
und
AI
die Schnelligkeit, mit der
started
sich
in the
unsere
cloud.
Zeit bewegt, ist
It started in the cloud for a good reason, because
immens.
it turns out
Also was
that
Technologie
AI
und
needs
Fortschritt angeht.
infrastructure. It's machine
Aber auch
learning.
in vielen Bereichen so
If the
langsam.
science says machine learning,
Vielleicht
then you
hilft
need a
AI.
machine to do the science. And so machine learning requires infrastructure, and the cloud data centers had infrastructure. They also have extraordinary computer science, extraordinary research, the perfect circumstance for AI to take off in the cloud and the CSPs. But that's not where AI is limited to. AI will go everywhere. And we're going to talk about AI in a lot of different ways. And the cloud service providers, of course, they like our leading edge technology. They like the fact that we have full stack, because accelerated computing, as you know, as I was explaining earlier, is not about the chip. It's not even just the chip in the library, the programming model. It's the chip, the programming model, and a whole bunch of software that goes on top of it. That entire stack is incredibly complex. Each one of those layers, each one of those libraries is essentially like SQL. SQL, as you know, is called in-storage
So, viel
computing.
Spaß, Fred,
It was the
beim
big
Zocken.
revolution of computation by IBM.
Nach dem Essen werde ich
SQL
heute auf jeden Fall auch ein
is
bisschen God
one
of War
library, just imagine.
Ragnarök weiterzocken. Da
I
freue
just
ich mich auch
showed you
schon
a
drauf.
whole bunch of them. And in the case of AI, there's a whole bunch more. So the stack is complicated.
Aber
They
vorher
also
gibt es
love
ein
the
Video auf
fact
dem Kanal.
that
Versprochen, Leute.
CSPs
Also
love
alle, die
that
heute dabei waren, ihr
Nvidia
habt die
CUDA
Sneak Preview.
developers
Es
are
wird
CSP
ein richtig
customers,
krasses Update
because
zu
in the
Intel
final
Arrow Lake
analysis, they're
geben.
building infrastructure for the world to use. And so the rich developer ecosystem is really valued and really deeply appreciated. Well, now that we're going to take AI out to the rest of the world has different system configurations, operating environment differences, domain-specific library differences, usage differences. And so AI, as it translates to enterprise IT, as it translates to manufacturing, as it translates to robotics or self-driving cars, or even companies that are starting GPU clouds. There's a whole bunch of companies, maybe 20 of them, who started during the Nvidia time. And what they do is just one
Okay,
thing.
Leute, gebt mir
They
eine Sekunde.
host GPUs.
Ich bin
They
gleich
call
wieder da.
themselves GPU clouds. And one of our great partners, CoreWeave, is in the process of going public, and we're super proud of them. And so GPU clouds, they have their own requirements. But one of the areas that I'm super excited about is edge. And today we announced today that Cisco, Nvidia, T-Mobile, the largest telecommunications company in the world, Cerberus ODC, are going to build a full stack for radio networks here in the United States. And that's going to be the second stack. So that this current stack we're announcing today will put AI into the edge. Remember, $100 billion of the world's capital investments each year is in the radio networks and all of the data centers provisioning for communications. In the future, there is no question in my mind that's going to be accelerated computing infused with AI. AI will do a far, far better job adapting the radio signals, the massive MIMOs, to the changing environments and the traffic conditions. Of course it would. Of course we would use reinforcement learning to do that. Of course MIMO is essentially one giant radio robot. Of course it is. And so we will, of course, provide for those capabilities. Of course, AI could revolutionize communications. You know, when I call home, you don't have to say but that few words, because my wife knows where I work, what that condition's like. Conversation carries on from yesterday She kind of remembers what I like, don't like, and oftentimes, just a few words, you communicated a whole bunch. The reason for that is because of context and human prior knowledge. Well, combining those capabilities could revolutionize
8 GB.
Look what it's doing for video
So wie die Gerüchte
look
scheinen.
what I just described
Da bin ich wieder
earlier
zurück.
in 3D graphics. And so of course we're going to do the same.
Ja,
for
12
Edge.
ist
So I'm
unwahrscheinlich.
super excited about the announcement that we made
Es
today.
wird bei der
T-Mobile,
5060
Cisco,
Ti
Nvidia, Servers, ODC, are going to build a
angeblich
full stack.
eine 16 GB Variante geben. Aber also ich bin nicht optimistisch bei der 5060 und das wäre natürlich echt schwach. Naja.
Well, AI is going to go into every industry. That's just one.
Habe ich was verpasst?
One of the earliest industries that AI went into was autonomous vehicles. The
Ja, im
moment I saw
Endeffekt,
AlexNet,
ich
and we've been
meine,
working on
4060,
computer vision for a long
4060
time.
Ti,
The
da
moment
wird
I
sich
saw
nicht
AlexNet
so viel
was
getan haben
such
zwischen
an
diesen drei Karten.
inspiring moment, such an exciting moment. It caused us to decide to go all in on building self-driving cars. So we've been working on self-driving cars now for over a decade. We build technology that almost every single self-driving car company uses. It could be either in the data center. For example, Tesla uses lots of Nvidia GPUs in the data center. It could be in the data center or the car. Waymo and Wave uses Nvidia computers in data centers as well as the car. It could be just in the car. It's very rare, but sometimes it's just in the car. Or they use all of our software in addition. We work with the car industry however the car industry would like us to work with them. We build all three computers, the training computer, the simulation computer, and the robotics computer, the self-driving car computer, all the software stack that sits on top of it, models and algorithms, just as we do with all of the other industries that I've demonstrated. And so today, I'm super excited to announce that GM has selected Nvidia to partner with them to build their future self-driving car fleet.
Wow. Wow, alright. Okay, General Motors partnert mit Nvidia.
The time for autonomous vehicles has arrived.
Ich sehe
And we're looking
die
forward
Aktie
to building with
hochschießen.
GM AI
Holy
in all three
smokes.
areas. AI for manufacturing, so they can revolutionize the way they manufacture. AI for enterprise, so they can revolutionize the way they work, design cars and simulate cars, and then also AI for in the car. So AI infrastructure for GM, partnering with GM, and building with GM their AI. So I'm super excited about that. One of the areas that I'm deeply proud of, and it rarely gets any attention, is safety, automotive safety. It's called halos. In our company, it's called halos. Safety requires technology from silicon to systems, the system software, the algorithms, the methodologies, everything from
Ja,
diversity
Casius, du hast, denke ich, alles
to
richtig
ensuring
gemacht damals mit der
diversity,
4080. Ist eine Top-Karte.
monitoring and
Die nächsten 2
transparency.
Jahre würde ich nicht
Explainability.
ansatzweise an irgendwas anderes denken.
All of these different philosophies have to be deeply ingrained into every single part of how you develop the system and the
Ich habe
software.
mir auch so eine persönliche
We're the
Marke
first
gesetzt.
company in the
Also
world, I believe,
Minimum
to
ein
have
Jahr,
every line of code
wenn
safety
alles gut läuft,
assessed.
2 Jahre auf
7
jeden Fall bei einer
million lines of
GPU
code
bleiben,
safety
neben
assessed.
dem, was ich für euch teste.
Our chip,
Das wäre
our
schon geil.
system
Also.
software, and our algorithms are safety
Bisschen was aus seiner
assessed
Hardware rausholen.
by
Das
third
ist die
parties
Devise.
that crawl through every line of code to ensure
Ach, KI.
that it is designed to ensure
KI ist gar nicht das Problem.
transparency,
Ne? Künstliche
and
Intelligenz
explainability.
bringt uns alle weiter.
We also
Aber der ganze
filed over 1,000
AI-Trend, ne?
patents. And during
Mit,
this GTC, and I really encourage you to do so,
den ganzen
is to go
Buzzwords
spend time
dahinter,
in the
nur um
Halos
Investoren
workshop,
abzuspeisen,
so that you could see all of
das
the different
wiederum
things
gefällt mir
that
nicht so.
comes together to ensure that
Weil-
cars of the future are going to be safe as well as autonomous.
weil oft ist
And
gar
so
nicht
this
irgendwas
is something I'm very
Stichfestes oder
proud of that
Handfestes hinter.
rarely
Ja,
gets any
sondern
attention.
Prognosen
And so
und
I thought I
was
would
auch
spend
immer
the
in
extra
der
time
Zukunft
this
vielleicht
time
damit
to talk
möglich
about
ist.
that.
Und
Okay,
am Ende wird
Nvidia
sich nur
Halos.
Geld gekrallt. Ja, okay, von einer 1080 auf eine 5080 ist dann wiederum ein gutes Upgrade. Ne?
The
Das
Waymo
lohnt sich.
robotaxis are incredible, but we made a video to share with you some of the technology we use to solve the problems of data and training and diversity so that we could use the magic of AI to go create AI. Let's take a look.
Nvidia is accelerating AI development for AVs with Omniverse and Cosmos. Cosmos prediction and reasoning capabilities support AI-first AV systems that are end-to-end trainable with new methods of development. Model distillation, closed-loop training, and synthetic data generation. First, model distillation. Adapted as a policy model, Cosmos's driving knowledge transfers from a slower, intelligent teacher to a smaller, faster student inferenced in the car. The teacher's policy model demonstrates the optimal trajectory, followed by the student model learning through iterations, until it performs at nearly the same level as the teacher. The distillation process bootstraps a policy model, but complex scenarios require further tuning. Closed-loop training enables fine-tuning of policy models. Log data is turned into 3D scenes for driving closed-loop in physics-based simulation using Omniverse neural reconstruction. Variations of these scenes are created to test a model's trajectory generation capabilities. Cosmos Behavior Evaluator can then score the generated driving behavior to measure model performance. Newly generated scenarios and their evaluation create a large dataset for closed-loop training, helping AVs navigate complex scenarios more robustly. Last, 3D synthetic data generation enhances AVs' adaptability to diverse environments. From log data, Omniverse builds detailed 4D driving environments by fusing maps and images and generates a digital twin
Ich
of
meine,
the
die
real world,
RTX 2080 ist eine
including
Raytracing-Karte.
segmentation, to guide Cosmos by classifying each pixel. Cosmos then scales the training data by generating accurate and diverse scenarios, closing the sim-to-real gap.
Ja, ein Hobby, da hast du recht.
Omniverse and Cosmos enable AVs to learn, adapt, and drive intelligently, advancing safer mobility.
Ich meine, Gaming ist zu einem Hochpunkt. VR, es gibt so viele Möglichkeiten, Grafik zu erleben
Nvidia is
und
the
da
perfect
sich einen
company
Riegel
to do that.
vorzuschieben, das bin ich ganz bei dir. Also
That's our destiny.
dafür gibt es viel zu
Use
coole Erfahrungen,
AI
die man
to
sammeln kann.
recreate AI. The technology that we showed you there is very similar to the technology that you're enjoying to take you to a digital twin we call Nvidia. All right, let's talk about data centers. That's not bad, huh? Gaussian splats, just in case. Gaussian splats. Well, let's talk about data centers. Blackwell is in full production, and this is what it looks like. It's an incredible, incredible, you know, for people, for us, this is a sight of beauty. Would you agree? This is, how is this not beautiful? How is this not beautiful? Well, this is a big deal because we made a fundamental transition in computer architecture. I just want you to know that, in fact, I've shown you a version of this about 3 years ago. It was called Grace Hopper, and the system was called Ranger. The Ranger system is about maybe about half of the width of the screen. And it was the world's first NVLink 32. 3 years ago, we showed Ranger working, and it was way too large, but it was exactly the right idea. We were trying to solve scale up. Distributed computing is about using a whole lot of different computers working together to solve a very large problem. But there's no replacement for scaling up before you scale out. Both are important, but you want to scale up first before you scale out. Well, scaling up is incredibly hard. There is no simple answer for it. You're not going to scale it up, you're not going to scale it out like Hadoop. Take a whole bunch of commodity computers, hook it up into a large network, and do in-storage computing using Hadoop. Hadoop was a revolutionary idea, as we know. It enabled hyperscale data centers to solve problems of gigantic sizes
im Bereich von
and
1,70 oder so?
using off-the-shelf computers. However, the problem we're trying to solve is so complex that scaling in that way would have simply cost way too much power, way too much energy. It would have never, deep learning would have never happened. And so the thing that we had to do was scale up first. Well, this is the way we scaled up. I'm not going to lift this. This is 70 pounds. This is the last generation system architecture.
Oh mein Gott.
HGX.
Google sagt,
This
irgendwo im Bereich
revolutionized computing
von
as we know it.
170
This
Zentimeter.
revolutionized artificial intelligence. This is 8 GPUs. 8
Ich hab gut
GPUs.
geschätzt.
Each one of them is kind of like this. Okay, this is 2 GPUs, 2 Blackwell GPUs in
Wir haben
one
das große
Blackwell
Mysterium
package.
gelöst. Jensen Huang,
2
1,70
Blackwell
Meter.
GPUs in one Blackwell package. And there are 8 of these underneath this. Okay? And this connects into what we call NVLink 8.
Das ist schon sexy, guck mal, ist alles
This
wassergekühlt,
then
ne?
connects to a
Schaut euch das
CPU
an.
shelf
Jesus.
like that. So there's dual CPUs, and that sits on top. And we connect it over PCI Express, and then many of these get connected with InfiniBand, which turns into what is an AI supercomputer. This is the way it was in the past. This is how we started. Well, this is as far as we scaled up before we scaled out. But we wanted to scale up even further. And I told you that Ranger took this system and scaled it up by another factor of 4. And so we had NVLink 32, but the system was way too large. And so we had to do something quite remarkable, re-engineer how NVLink worked and how scale-up worked. And so the first thing that we did was we said, listen, the NVLink switches are in this system embedded on the motherboard. We need to disaggregate the NVLink system and take it out. So this is the NVLink system. Okay, this is an NVLink switch. This is the highest performance switch the world's ever made. And this makes it possible for every GPU to talk to every GPU at exactly the same time at full bandwidth. Okay, so this is the NVLink switch. We disaggregated it, we took it out, and we put it in the center of the chassis. So there are 18 of these switches in 9 different racks, 9 different switch trays, we call them. And then the switches are disaggregated. The compute is now sitting in here. This is equivalent to these 2 things in compute. What's amazing is this is completely liquid cooled. And by liquid cooling it, we can compress all of these compute nodes into one rack. This is the big change of the entire industry. All of you in the audience, I know how many of you are here. I want to thank you for making this fundamental shift from integrated NVLink to disaggregated NVLink, from air-cooled to liquid-cooled, from 60,000 components per computer or so, to 600,000 components per rack, 120 kilowatts, fully liquid cooled, and as a result, we have a 1 exaflops computer in one rack.
Gestört.
Isn't it incredible?
Also das ist wirklich krank.
So this is the compute node. This is the compute node, okay? And that now fits in one of these. Now 3,000 pounds, 5,000 cables, about 2 miles worth. Just an incredible electronics. 600,000 parts, I think that's like 20 cars. 20 cars worth of parts. And integrates into one supercomputer. Well, our goal is to do this. Our goal is to do scale up. And this is what it now looks like. We essentially wanted to build this chip. It's just that no reticle limits can do this. No process technology can do this. It's 130 trillion transistors. 20 trillion of it is used for computing. So it's not like you can't reasonably build this anytime soon. And so the way to solve this problem is to disaggregate it, as I described, into the Grace Blackwell NVLink 72 rack. But as a result, we have done the ultimate scale-up. This is the most extreme scale-up the world has ever done. The amount of computation that's possible here, the memory bandwidth, 570 terabytes per second. Everything in this machine is now
Oh ja, deutlich mehr Geld, als die Gaming-Industrie abwirft.
And you have,
Und mit den Partnern, die Nvidia hier genannt hat, also das wird noch ein ziemlich langes und ziemlich hohes High für die ganze AI-Branche, bevor es dann richtig bergdown geht.
A lot of people misunderstood to be easy. And in fact, it is the ultimate extreme computing problem.
Naja, aber bis dahin haben sie die Welt unterm Nagel.
And the reason for that is very simple.
Also
Inference
die AI
is token generation by a factory. And a factory is revenue and profit generating, or lack of. And so this factory
Das glaube ich
has
nicht,
to be
Nick.
built
Also
with extreme
ich denke, sie haben jetzt einfach mit dieser aktuellen Generation keinen Fortschritt machen können. Deswegen wird einfach in deren industriellen Sparte Geld gescheffelt. Und ja, warum aus einem Update-Zyklus alle 2 Jahre nicht 4 Jahre machen und trotzdem denselben Abwurf erzielen. Ne? Ich glaube, Nvidia ist noch lange nicht mit Gaming fertig.
Put a prompt into ChatGPT, what comes out is tokens. Those tokens are reformulated into words. You know, it's more than a token per word.
Ja, die Frage, die Leistung einer 5090, die Frage ist, wie schnell sich Grafik und die Gaming-Industrie durch AI entwickeln wird. Ich glaube nicht. Man sollte jetzt immer nur auf Rohleistung gehen. Ich glaube, dafür wird sich viel zu viel maßgeblich ändern. Also eine 5090 ist in keiner Relation preislich zu rechtfertigen als Gaming-Card. Aber ja, für jeder, der so viel Geld ausgegeben hat, kann man nur hoffen, dass sie sich gut halten wird. Also abgesehen von dem schmelzenden 12 Volt HPWR.
And so it talks to itself, just like we talk to ourselves. And so the more tokens you generate, the smarter your AI. But if you take too long to answer a question, the customer's not going to come back. This is no different than web search. There is a real limit to how long it can take before it comes back with a smart answer. And so you have these 2 dimensions that you're fighting against. You're trying to generate a whole bunch of tokens, but you're trying to do it as quickly as possible. Therefore, your token rate matters. So you want your tokens per second for that one user to be as fast as possible. However, in computer sciences and factories, there's a fundamental tension between latency response time and throughput. And the reason is very simple. If you're in the large, high-volume business, you batch up. It's called batching. You batch up a lot of customer demand.
Ja, also wenn alles auf Server ausgelagert wird, ich meine, GeForce Now is the future, sobald die Bandbreite nicht mehr das Limit ist. Warum Hardware, warum E-Waste? Ja? Stromverbrauch wird gesenkt. Das Problem der Kühlung fällt weg. Einfach auf einem Notebook oder auf einem Smartphone.
No different for AI factories that are generating tokens. And so you have these 2 fundamental tensions. On the one hand,
Bandbreite
You would
ist
like
alles,
the
was wir brauchen.
customer's quality of service to be as good as possible. Smart AIs that are super
Kommunikationsschnittstellen,
fast.
Streaming-Schnittstellen.
On the other hand, you're trying to get your data center to produce tokens for as many people as possible so you can maximize your revenues. The perfect answer is to the upper right. Ideally, the shape of that curve is a square that you could generate very fast tokens per person up until the limits of the factory, but no factory can do that.
Der
So
Max
it's
Grant
probably some
sagt,
curve,
ob er was verpasst
And
hat.
your goal
Nein.
is to maximize the area under the curve,
Er,
okay, the product of X and Y, and the further you push out,
Jensen
more likely
hat uns an Skynet
it
verkauft.
means
That's
the
right.
better of a factory that you're building. Well, it turns out that in tokens per second for the whole factory and tokens per second response time, one of them requires enormous amount of computation, flops, and then the other dimension requires an enormous amount of bandwidth and flops. And so this is a very difficult problem to solve. The good answer is that you should have lots of flops and lots of bandwidth and lots of memory and lots of everything. That's the best answer to start, which is the reason why this is such a great computer. You start with the most flops you can, the most memory you can, the most bandwidth you can, of course, the best architecture you can, the most energy efficiency you can, and you have to have a programming model that allows you to run software across all of this insanely hard so that you could do this. Now let's just take a look at this one demo to give you a tactile feeling of what I'm talking about. Please play it.
Traditional LLMs capture foundational knowledge, while reasoning models help solve complex problems with thinking tokens.
Oh, Fun Fact, Yama
Here,
4
a
kommt
prompt
nächste
asks to
Woche,
seat people
übernächste
around a
Woche
wedding
raus,
table
am
while
29.
adhering to constraints like traditions, photogenic angles, and feuding family members.
Spannend.
Traditional LLM answers quickly with under 500 tokens. It makes mistakes in seating the guests, while the reasoning model thinks with over 8,000 tokens to come up with the correct answer. It takes a pastor to keep the peace.
Okay. As all of you know, if you have a wedding party of 300,
Danke für den Support. Ja,
And
gerne.
you're trying to find
Pusht
the
gerne die
perfect-
Daumen nach oben. Also
the
für
optimal seating for
die ganzen
everyone.
über 50 Zuschauer, da gehen 50
that's a
Daumen nach oben,
problem that
Leute.
only AI can
Würde
solve
mich freuen. Wir sind jetzt eine
or a
Stunde live.
mother-in-law can solve.
Wäre auf jeden Fall geil.
And so that's one of those problems that co-op cannot solve. Okay, so what you see here is that we gave it a problem that requires reasoning, and you saw R1 goes off and it reasons about it, tries all these different scenarios, and it comes back and it tests its own answer. It asks itself whether it did it right. Meanwhile, the last generation language model does a one-shot. So the one-shot is 439 tokens. It was fast, it was effective, but it was wrong. So it was 439 wasted tokens. On the other hand, in order for you to reason about this problem, and this is just that was actually a very simple problem. You know, you just give it a few more difficult variables, and it becomes very difficult to reason through. And it took 8,000, almost 9,000 tokens. And it took a lot more computation because the model's more complex. Okay, so that's one dimension. Before I show you some results, let me explain something else. So the answer, if you look at Blackwell, you look at the Blackwell system, and it's now the scaled up NVLink 72. The first thing that we have to do is we have to take this model, and this model is not small. It's, you know, in the case of R1, people think R1 is small, but it's 680 billion parameters. Next generation models could be trillions of parameters. And the way that you solve that problem is you take these trillions and trillions of parameters and this model, and you distribute the workload across the whole
Den gibt es
system
bestimmt schon auf
of
eBay
GPUs.
gescalpt
You
zum
can
doppelten
use,
Preis.
Tensor parallel. You can take one layer of the model and run it across multiple GPUs. You could take a slice of the pipeline and call that pipeline parallel and put that on multiple GPUs. You could take different experts and put it across different GPUs. We'll call it expert parallel. The combination of pipeline parallelism and tensor parallelism and expert parallelism, the number of combinations is insane. And depending on the model, depending on the workload, depending on the circumstance, how you configure that computer has to change so that you can get the maximum throughput out of it. You also sometimes optimize for very low latency, sometimes you try to optimize for throughput, and so you have to do some in-flight batching. A lot of different techniques for batching and aggregating work. And so the software, the operating system for these AI factories is insanely complicated. Well, one of the observations, and this is a really terrific thing about having a homogeneous architecture like NVLink 72, is that every single GPU could do all the things that I just described. And we observe that these reasoning models are doing a couple of phases of computing. One of the phases of computing is thinking. When you're thinking, you're not producing a lot of tokens. You're producing tokens that you're maybe consuming yourself. You're thinking. Maybe you're reading. You're digesting information. That information could be a PDF. That information could be a website. You could literally be watching a video, ingesting all of that at super linear rates. And you take all of that information and you then formulate the answer, formulate a plan to answer. And so that digestion of information, context processing, is very flops intensive. On the other hand, during the next phase is called decode. So the first part we call prefill. The next phase of decode requires floating point operations, but it requires an enormous amount of bandwidth. And it's fairly easy to calculate. You know, if you have a model and it's a few trillion parameters, well, it takes a few terabytes per second. Notice I was mentioning 576 terabytes per second. It takes terabytes per second to just pull the model in from HBM memory and to generate literally one token.
So, der Max Grant sagt, dass die PS5 Pro in Kombination mit der PS Portal enorm gut, wenn die Verbindung klappt, läuft. Also ganz ehrlich, ich bin ein Verfechter von VR. Ja? Also da mache ich mal ganz kurz den Jensen ein bisschen leiser. Für mich ist die kabellose Bandbreite und Verbindung teilweise in manchen Szenarien schon so gut. Also jeder, der schon mal Steam Link ausprobiert hat, also zum Beispiel den lokalen PC als Rendermaschine benutzt hat und zum Beispiel sozusagen über Steam Link auf das Handy, ja, auf ein Android-Gerät gestreamt hat. Das ist so, als ob du dein Handy in eine PS Portal verwandelst. Ja, das funktioniert genauso gut. Und es gibt so viele Controller-Upgrades, ja, für Smartphones heutzutage. Da kann man im Endeffekt jetzt schon genau das tun und lokal, auch ohne GeForce Now, sich sozusagen diese gesamte Renderleistung holen, wenn man natürlich eine Grafikkarte hat, die das drauf hat. Und genauso dann auch in VR, ja, Virtual Reality, die Meta Quest, ja, kabelloses VR, lokal rendern und streamen sozusagen, das läuft alles schon sowas von krass. Und deswegen, ich bin der festen Überzeugung, es dauert nicht mehr lange, dann sind lokale Grafikkarten vielleicht auch nicht mehr zwingend notwendig oder halt bis zu einem gewissen Prozess durch AI, ja, ich meine DLSS, also Supersampling in dem Fall, wird ja eh schon aufgeputscht, ja, und irgendwann mal ist es soweit. Irgendwann mal werden Bilder halt zum Verwechseln generiert, ohne den Unterschied zu haben. Und für Probleme, die jetzt bestehen, sei es jetzt irgendwie Schatten oder Licht, das für Probleme sorgt, ja, das sind alles Probleme, die sind lösbar. Und Nvidia wird Lösungen finden und DLSS 4 ist, denke ich, jetzt erst einmal ein Zwischenschritt gewesen, einen vermeintlichen Refresh sozusagen als neue Generation zu verkaufen. Aber die Game-Industrie und auch allgemein Software ändert sich so rapide. Ja, ich bin sehr gespannt, was die Zukunft für uns bietet.
Super busy. And it's not really generating that many tokens. On the other hand, when you're chatting with the chatbot, and millions of us are doing the same thing, it is very token generation heavy. It's very decode heavy, okay? And so depending on the workload, we might decide to put more GPUs into decode, depending on the workload, put more GPUs into prefill. Well, this dynamic operation is really complicated. So I've just now
Unser Prediger Jensen.
pipeline parallel, tensor parallel.
Predigt gerade für sämtliche Geldgeber und Investoren.
In-flight batching,
Die wollen eigentlich nur wissen,
disaggregated inferencing,
wie hoch sind die Zahlen. Und Jensen hat es direkt am Anfang schon gesagt. Er hat 1 Trillion gesagt. Das ist so schön ungreifbar, dass bestimmt die Aktie hochgegangen ist.
And so today we're announcing the Nvidia Dynamo.
Okay, da geht die
Nvidia Dynamo
Anfrage
does all
rein.
that. It is essentially the operating system of an AI factory. Whereas in the past, in the way that we ran data centers, our operating system would be something like VMware. And we would orchestrate, and we still do, you know, we're a big user, we orchestrate a whole bunch of different enterprise applications running on top of our enterprise IT. But in the future, the application is not enterprise IT, it's agents. And the operating system is not something like VMware, it's something like Dynamo. And this operating system is running on top of not a data center, but on top of an AI factory.
Das ist eine spannende Theorie, sozusagen Cloud generiert 60 FPS und lokal wird 120 oder 360 FPS draus. Das ist ja, sehr gut möglich, ne? Nicht unwahrscheinlich. Wer sagt, dass zum Beispiel moderne Monitore oder Fernseher vielleicht sogar auch implementierte Prozessoren haben werden, die viel mehr ja, die gesamte Plattform voranschreiten werden. Who knows? Ich meine, just saying, ja, Samsung bringt, ich glaube, in 1-2 Wochen einen neuen 3D-Monitor raus. Ja, 2025, 3D-Monitore werden wieder populär. Und zwar einer, der lokal, ohne Brille, 3D-Bilder generiert. Da bin ich sehr gespannt drauf, um ehrlich zu sein. Also jetzt nicht, weil es wahrscheinlich günstig wird oder super toll, aber es ist ein sehr interessanter Schritt.
Okay, so now we're going to have to wait until we scale up all these infrastructure, but in the meantime, we've done a whole bunch of very in-depth simulation. We have supercomputers doing simulation of our supercomputers, which makes sense. And I'm now going to show you the benefit of everything that I've just said.
Ja, bin ich ganz bei dir. 4K, 60 FPS reichen, dicke.
On the x-axis is tokens per second throughput. Excuse me, on the y-axis, tokens per second throughput of the factory, and the x-axis, tokens per second of the user experience. And you want super smart AIs, and you want to produce a whole bunch of it. This is Hopper. Okay, so this is Hopper, and it can produce for one user, for each user, about 100 tokens per second.
Inference performance.
This is
inference.
8 GPUs, and it's connected with InfiniBand, and I'm normalizing it to tokens per second per megawatt. So it's a 1 megawatt data center, which is not a very large AI factory, but anyhow, 1 megawatt, okay? And so it can produce, for each user, 100 tokens per second, and it can produce at this level, whatever that happens to be, 100,000 tokens per second for that 1 megawatt data center. Or it can produce about 2.5 million tokens per second, 2.5 million tokens per second for that
Damit
AI
messt man
factory
sozusagen die Reaktionszeit eines AI-Modells bzw. eines Sprachmodells, das trainiert wurde.
All right, so nod. All right, because this is where, you know, every GTC there's the price for entry. You guys know, and it's like you get tortured with math. Okay, this is the only at Nvidia do you get tortured with math. All right, so Hopper, you get 2.5. Now, what's that 2.5 million? How do you translate that? 2.5 million. Remember, ChatGPT is like $10 per million tokens. Right? $10 per million tokens. Let's pretend for a second that's I think the $10 per million tokens is probably down here, okay? I'd probably say it's down here, but let me pretend it's up there, because 2.5 million, 10, so $25 million per second. Does that make sense? That's how you think through it. Or on the other hand, if it's way down here, then the question is, so it's 100,000, just divide that by 10, okay? $250,000 per factory per second. And then, it's 31 million, 30 million seconds in a year, and that translates into revenues for that 1 megawatt data center. And so that's your goal. On the one hand, you would like your token rate to be as fast as possible so that you can make really smart AIs. And if you have smart AIs, people pay you more money for it. On the other hand, the smarter the AI, the less you can make in volume. Very sensible trade-off. And this is the curve we're trying to bend. Now, what I'm just showing you right now is the fastest computer in the world, Hopper. It's the computer that revolutionized everything. And so how do we make that better? So the first thing that we do is we come up with Blackwell with NVLink 8. Same Blackwell, that one same compute, and that one compute node with NVLink 8 using FP8. And so Blackwell is just faster. Faster, bigger, more transistors, more everything. But we like to do more than that, and so we introduce a new precision. It's not quite as simple as 4-bit floating point, but using 4-bit floating point, we can quantize the model, use less energy to do the same. And as a result, when you use less energy to do the same, you could do more. Because remember, one big idea is that every single data center in the future will be power limited. Your revenues are power limited. You could figure out what your revenues are going to be based on the power you have to work with. This is no different than, like many other industries. And so we are now a power limited industry. Our revenues will associate with that. Well, based on that, you want to make sure you have the most energy efficient compute architecture you can possibly get. Then we scale up with NVLink 72. Does that make sense? Look at the difference between that, NVLink 72 FP4, and then, because our architecture is so tightly integrated, and now we add Dynamo to it, Dynamo can extend that even further. Are you following me? So Dynamo also helps Hopper, but Dynamo helps Blackwell incredibly. Now, yep. Only at GTC do you get an applause for that. And so now notice what I put, those two shiny parts, that's kind of where your max Q is. That's likely where you'll run your factory operations. You're trying to find that balance between maximum throughput and maximum quality of AI. Smartest AI, the most of it. Those two, that XY intercept is really what you're optimizing for. And that's what it looks like if you look underneath those two squares. Blackwell is way, way better than Hopper. And remember, this is not ISO chips. This is ISO power. This is ultimate Moore's Law. This is what Moore's Law was always about in the past. And now here we are, 25x in one generation as ISO power. This is not ISO chips, it's not ISO transistors, it's not ISO anything. ISO power, the ultimate limiter. There's only so much energy we can get into a data center. And so within ISO power, Blackwell is 25 times. Now here's that rainbow. That's incredible. That's the fun part. Look, all the different underneath the Pareto, the frontier Pareto, we call it the frontier Pareto, under the frontier Pareto are millions of points we could have configured the data center to do. We could have parallelized and split the work and sharded the work in a whole lot of different ways. And we found the most optimal answer, which is the Pareto, the frontier Pareto, okay, the Pareto frontier. And each one of them,
ich sehe schon, es geht im Chat in ganz andere Richtung.
Which is the reason why
Aber ja, definitiv spannende
says very, very
Möglichkeiten, die die
clearly,
Zukunft offen hält.
you want a programmable architecture that is as homogeneously fungible as possible. Because the workload changes so dramatically across the entire frontier.
Übersichtlich ist der Graph nicht.
And look,
Und meine
we got
Tagesaufnahmefähigkeit
on the top,
neigt sich der
Expert Parallel 8,
Grenze
batch of
zu.
3000,
Ich hoffe, der Jensen kommt gleich zu einem
Dynamo
Schluss.
off. In the middle, Expert Parallel 64 with the 26% is used for context, so Dynamo is turned on, 26% context, the other 74% is not. Batch of 64, and Expert Parallel of 64 on one, Expert Parallel 4 on the other. And then down here, all the way to the bottom,
Erklärt sich das jetzt
you got
gerade selber?
Tensor Parallel 16 with Expert Parallel 4, batch of 2, 1% context. The configuration of the computer is changing across that entire spectrum. And then this is what happens. So this is with input sequence length. This is a kind of a commodity test case. This is a test case that you can benchmark relatively easily. The input is 1,000 tokens. The output is 2,000. Notice earlier, we just showed you a demo where the output is very simply 9,000, right? 8,000, okay? And so obviously this is not representative of just that one chat. Now this one is more representative, and this is what, the goal is to build these next generation computers for next generation workloads. And so here's an example of a reasoning model. And in a reasoning model, Blackwell is 40 times the performance of Hopper. Straight up. Pretty amazing. I've said before, somebody actually asked, why would I say that? But I said before that when Blackwell starts shipping in volume, you couldn't give Hoppers away. And this is what I mean. And this makes sense. If you're still looking to buy a Hopper, don't be afraid. It's okay. But I'm the chief revenue destroyer. My sales guys are going, oh no, don't say that. There are circumstances where Hopper is fine. That's the best thing I could say about Hopper. There are circumstances where you're fine. Not many. If I had to take a swing. And so that's kind of my point.
Seht ihr, genau das ist das, was ich meine. Ja, mit Grafikkarten und Gaming.
Because the workload is so intense and you're building these things, they're factories.
Wenn dir jemand in einem oder 2 Jahren sagt, die 5090 ist just fine, ja, und du über 3.000 Euro dafür ausgegeben hast, dann steht das in keinem Verhältnis mehr.
You have, based on Hoppers, you have 45,000 dies, 1,400 racks, and it produces 300 million tokens per second, okay? And then this is what it looks like with Blackwell. You have 86, yeah, I know. That doesn't make any sense. Okay, so we're not trying to sell you less. Okay, our sales guys are going, Jensen, you're selling them less. This is better. Okay, and so anyways, the more you buy, the more you save.
Da kam der Sales Pitch, auf den wir alle gewartet
It's even
haben.
better than that. Now the more you buy, the more you make. And so anyhow, remember, everything is in the context, everything is now in the context of AI factories.
Es ist nur eben der Wettkampf gegen die Zeit, der hier in dieser Relation einen Strich durch die Rechnung macht. Denn umso mehr du kaufst, ja, umso mehr sparst du in Anführungsstrichen oder machst Geld damit, aber die Zeit, in der du diese Gewinne als Unternehmen erzielen kannst, ja, sind halt auch einfach nur an Relationen und Zeit gebunden. So. Und diese Rechnung geht halt nicht auf, wenn unsere Technologie so schnell wächst, aber wir nicht mitwachsen. Das ist nicht nachhaltig, das will ich damit sagen. nicht nachhaltig und nicht ökonomisch für das Unternehmen.
The world is racing to build state-of-the-art, large-scale AI factories. Bringing up an AI gigafactory is an extraordinary feat of engineering, requiring tens of thousands of workers from suppliers, architects, contractors, and engineers to build, ship, and assemble nearly 5 billion components and over 200,000 miles of fiber, nearly the distance from the Earth to the Moon. The Nvidia Omniverse blueprint for AI factory digital twins enables us to design and optimize these AI factories long before physical construction starts. Here, Nvidia engineers use the blueprint to plan a 1 gigawatt AI factory, integrating 3D and layout data of the latest Nvidia DGX superpods and advanced power and cooling
Krass, oder?
systems from Vertiv and Schneider Electric, and optimized topology from Nvidia Air, a framework for simulating network logic, layout, and protocols. This work is traditionally done in silos. The Omniverse blueprint lets our engineering teams work in parallel and collaboratively, letting us explore various configurations to maximizing TCO and power usage effectiveness. Nvidia uses Cadence Reality Digital Twin, accelerated by CUDA and Omniverse libraries, to simulate air and liquid cooling systems. And Schneider Electric with ETAP, an application to simulate power block efficiency and reliability.
Max Grant, warte
Real-time
auf die
simulation
Nintendo
lets
Switch
us
2.
iterate and run
Es wird kommen.
large-scale what-if scenarios in seconds versus hours. We use the digital twin to communicate instructions to the large body of teams and suppliers, reducing execution errors and accelerating time to bring up. And when planning for retrofits or upgrades, we can easily test and simulate cost and downtime, ensuring a future-proof AI factory.
Das war eine sehr spektakuläre Demo, muss ich zugestehen.
This is the first time anybody who builds data centers says, oh, that's so beautiful. All right, I got a race here because turns out I got a lot to tell you. And so if I go a little too fast, it's not because I don't care about you, it's just I got a lot of information to go through. All right, so first, our roadmap. We're now in full production of Blackwell. Computer companies all over the world are ramping these incredible machines at scale. And I'm just so pleased and so grateful that all of you worked hard on transitioning into this new architecture. And now, in the second half of this year, we'll
So, jetzt kommt er wenigstens ein bisschen in die
transition
Pötte.
into the upgrade.
Jensen sagt, er haut jetzt alle Informationen raus, kurz und knackig nach dem stundenlangen Sales Pitch.
New instruction for attention is 1.5 times more memory. All that memory is useful for things like KV cache. It's 2 times more bandwidth, okay, for networking bandwidth. And so you're gonna now that we have the same architecture, we'll just kind of gracefully glide into that, and that's called Blackwell Ultra, okay?
Let's
So
go.
that's coming second half
Ultra
of this year.
ist immer
Now,
besser.
there's a reason why this is the only product announcement in any company where everybody's going.
Oh, das heißt, diese Generation wird es Super nicht mehr geben, sondern Ultra. Freue ich mich schon drauf, auf den Refresh.
And in fact, that's exactly the response I was hoping to get. And here's why. Look, we're building AI factories and AI infrastructure. It's going to take years of planning. This isn't like buying a laptop. This isn't discretionary spend. This is spend that we have to go plan on. And so we have to plan on having, of course, the land and the power, and we have to get our CapEx ready, and we get engineering teams, and we have to lay it out a couple, 2-3 years in advance, which is the reason why I show you our roadmap a couple, 2-3 years in advance, so that we don't surprise you in May. Hi, in another month, we're going to go to this incredible new system. I'll show you an example in a second. And so we plan this out in multiple years. The next click, 1 year out, is named after an astronomer, and her grandkids are here. Her name is Vera Rubin. She discovered dark matter. Okay, yep.
Dunkle Materie von Rubin, ja.
Vera Rubin is incredible because the CPU is new. It's twice the performance of Grace, and more memory, more bandwidth, and yet just a little tiny 50-watt CPU. It's really quite incredible. Okay? And Rubin, brand new GPU, CX9, brand new networking.
Okay,
smart NIC.
2026.
NVLink 6, brand new NVLink, brand new memory.
Das ist krass,
HBM4.
wie sehr sie sich in die Karten
Basically,
gucken lassen.
everything is brand new, except for the chassis.
Tun sie das, um
And this way,
sozusagen
we could take a whole
die
lot of risk
Last
in one direction
von Blackwell zu nehmen,
and not risk a whole bunch of
weil
other
sie wissen,
things,
dass sie eh nicht den
related to
gesamten
the
Markt
infrastructure.
bedienen können.
And so Vera Rubin,
Ja.
NVLink 144,
Weil
is
die
the
Investoren
second
sind
half
dadurch
of
natürlich schön
next year.
zufriedengestellt. Die
Now,
Verkaufszahlen werden
one
trotzdem
of the things that I
am
made a
maximalen
mistake
Peak sein.
And so I just need you to make this pivot.
Aber
We're going to do
das ist
this one
natürlich
time.
das Jonglieren mit Umsatz, ne?
Blackwell is
Was
really
ist
two
möglich?
GPUs in one Blackwell chip.
So wie ich gesagt habe, ja.
We call that one chip a
Bis zu einem
GPU,
gewissen
and that was
Punkt
wrong.
sind halt die
And the reason for that is
Kapazitäten
it
ausgeschöpft.
screws up all the NVLink nomenclature and things like that. So going forward, without going back to Blackwell to fix it, going forward, when I
Tatsächlich
say
soll Steam auch an einer
NVLink
neuen Konsole
144,
arbeiten.
it just means
Und
that
who
it's
knows?
connected to 144
Aber wenn
GPUs.
was von
And
Steam
each
kommt, dann
one of
wird es
those
auf
GPUs is a
AMDs
GPU
FSR
die,
basieren, weil
and it could be assembled
Steam Deck,
in some
das nächste
package.
Steam Deck,
How it's assembled
das
could change
steht
from time to time.
auf jeden Fall auch auf
Okay?
der Agenda.
And so each
mit
GPU
neuer
dies a
APU
GPU,
von AMD.
each NVLink is connected to the GPU. And so Vera Rubin NVLink 144. And then this now sets the stage for the second half of the year, the following year, we call Rubin Ultra. Okay, so Vera Rubin Ultra. I know. This one is where you go, all right, so this is Vera Rubin, Rubin Ultra, second half of 27. It's NVLink 576, extreme scale up. Each rack is 600 kilowatts, 2.5 million parts, okay? And obviously a whole lot of GPUs. And everything is X factor more. So 14 times more flops, 15 exaflops. Instead of one exaflop, as I mentioned earlier, is now 15 exaflops.
Tja, geht dann aber noch die Rechnung auf. If you buy more, you save more, you make more? Ich glaube nicht. Ja, also das muss man sich auf der Zunge zergehen lassen, wie viel Geld hier tatsächlich im Raum ist.
I don't mean aggregate, I mean scale up bandwidth. And of course, a brand new NVLink switch and CX9, okay? And so notice 16 sites, 4 GPUs in one package, extremely large NVLink. Now just put that in perspective. This is what it looks like, okay? Now this is going to be fun. So you are just literally ramping up Grace Blackwell at the moment, and I don't mean to make it look like a laptop, but here we go. Okay, so this is what Grace Blackwell looks like, and this is what Rubin looks like. ISO dimension. And so this is another way of saying, before you scale out, you have to scale up. Does that make sense? Before you scale out, you scale up. And then after that, you scale out with amazing technology that I'll show you in just a second. All right, so first you scale up, and then now that gives you a sense of the pace at which we're moving. This is the amount of scale up flops.
Da, wo ihr jetzt die Blackwell seht, könnt ihr eure 5090
Hopper
hinpacken.
is 1x, Blackwell 68x, Rubin is 900x. Scale up flops.
Die Relation.
And then if I turn it into essentially your TCO, which is power on top, power per, and the underneath is the area underneath the curve that I was talking to you about, the square underneath the curve, which is basically flops times bandwidth, okay? So the way you think about a very easy gut check on whether your AI factories are making progress is watts divided by those numbers. And you can see that Rubin is going to drive the cost down tremendously, okay? So that's very quickly NVIDIA's roadmap. Once a year like clock ticks, once a year. Okay,
Once
how do
a
we scale
year.
up? Well, we were preparing to scale out. That was scale up, was NVLink. Our scale out network is InfiniBand and Spectrum-X. most were quite surprised that we came into the Ethernet world. And the reason why we decided to do Ethernet is if we could help Ethernet become like InfiniBand, have the qualities of InfiniBand, then the network itself would be a lot easier for everybody to use and manage. And so we decided to invest in Spectrum. We call it Spectrum X, and we brought to it
Die Aussage, also lohnt sich nichts. Nach Jensens Aussage lohnt sich das, was man sich jetzt leisten kann, um das Maximum aus dem zu ziehen, was man jetzt erfahren kann. Und das würde ich auch im übertragenen Sinne nicht nur im industriellen, sondern auch bei Grafikkarten und Gaming sehen. Ne, deswegen einfach das nehmen, was für einen gerade richtig erscheint. Es ist alles immer wieder neu. Von daher braucht man sich gar nicht beirren lassen.
Is the largest enterprise networking company to take Spectrum X and integrate it into their product line so that they could help the world's enterprises become AI companies. We're at 100,000 with CX7. Now CX8's coming, CX9's coming. And during Ruben's time frame, we would like to scale out the number of GPUs to many hundreds of thousands. Now, the challenge with scaling out GPUs to many hundreds of thousands is the connection of the scale out. This connection on scale up is copper. We should use copper as far as we can, and that's, call it a meter or two.
The more you don't buy, the more you don't save. That's right.
Very
That's
high
the mind trick.
reliability, very good energy efficiency, very low cost. And so we use copper as much as we can on scale up, but on scale out, where the data centers are now the size of the stadium, we're going to need something much long distance running. And that's just where silicon photonics comes in. The challenge of silicon photonics has been that the transceivers consume a lot of energy. To go from electrical to photonic has to go through a SerDes, go through a transceiver and a SerDes, several SerDes. And so each one of these, am I alone? Is anybody? What happened to my networking guys? Can I have this up here? Yeah, let's bring it up so I can show people what I'm talking about. Okay, so first of all, we're announcing Nvidia's first co-packaged option silicon photonic system. It is the world's first 1.6 terabit per second CPO. It is based on a technology called micro-ring resonator modulator, and it is completely built with this incredible process technology at TSMC that we've been working with for some time. And we partnered with just a giant ecosystem of technology providers to invent what I'm about to show you. This is really crazy technology. Crazy technology. Now, the reason why we decided to invest in MRM is so that we could prepare ourselves using MRM's incredible density
also der Chip
and power,
sieht wild aus,
better
das
density
gesamte
and power
Silicon
compared
Package.
to Moxander, which is used for telecommunications when you drive from one data center to another data center in telecommunications, or even in the transceivers that we use Moxander, because the density requirement is not very high until now. And so if you look at these transceivers, this is an example of a transceiver.
Ist gerade was passiert? Irgendwas kaputt gegangen?
They did a very good job tangling this up for me. Oh, wow. Thank you. Oh, mother of God.
Jetzt geht kein
Weg
Weg zurück.
Turn reasoning on.
Woo! Live action! Live action.
It's not as easy as you think. These are squirrely little things. All right, so this one right here, this is 30 watts. Just so keep your
Das war
number,
sowas
30
von
watts.
unscripted.
And if you get it on, if you
Einfach
buy it in high
geil.
volume, it's
Also
$1,000.
das hat ein Nvidia gerade auf jeden Fall 10 Karma-Punkte
On
gegeben.
this side is electrical. On this side is optical. Okay, so optics come in through the the yellow, you plug this into a switch. It's electrical on this side. There's transceivers, lasers, and it's a technology called Mach-Zehnder, and incredible.
Er ist ein sehr guter Stand-up-Comedian.
We use this to go from the GPU to the switch to the next switch, and then the next switch down, and the next switch down to the GPU, for example. And so each one of these, if we had 100,000 GPUs, we would have 100,000 of this side, and then another, 100,000, which connects the switch to the switch, and then on the other side, I'll attribute that to the other NIC. If we had 250,000, we'll add another layer of switches, and so each GPU, every GPU, 250,000, every GPU would have 6 transceivers. Every GPU would have 6 of these plugs, and these 6 plugs would add 180 watts per GPU, 180 watts per GPU, and $6,000 per GPU, okay? And so the question is, how do we scale up now to millions of GPUs? Because if we had 1 million GPUs, multiplied by 6, right, it would be 6 million transceivers times 30 watts, 180 megawatts of transceivers. They didn't do any math, they just moved signals around. And so the question is, how could we afford, and as I mentioned earlier, energy is our most important commodity. Everything is related ultimately to energy. So this is going to limit our revenues, our customers' revenues, by subtracting out 180 megawatts of power. And so this is the amazing thing that we did. We invented the world's first MRM micro mirror, and this is what it looks like. There's a little waveguide. You see that on that waveguide goes to a ring. That ring resonates, and it controls the amount of reflectivity of the waveguide as it goes around, and it limits and modulates the energy, the amount of light that goes through. And it shuts it off by absorbing it or pass it on. Okay, it turns the light, this direct continuous laser beam, into ones and zeros. And that's the
crazy
miracle. And that technology is then, that photonic IC is stacked with the electronic IC, which is then stacked with a whole bunch of micro lenses, which is stacked with this thing called fiber array. These things are all manufactured using this technology at TSMC called, they call it COUPE, and packaged using a 3D CoWoS technology, working with all of these technology providers, a whole bunch of them, the names I just showed you earlier, and it turns it into this incredible machine. So let's take a look at the video of it.
Yeah, let's go with the video. Wow. Wild. Was
Just
für
a
eine
technology marvel.
Bandbreite
And they turn into
dadurch.
these switches. Our InfiniBand switch, the silicon
Wild.
is working fantastically. Second half of this year, we will ship the silicon photonics switch in the second half of this year. In the second half of next year, we'll ship the Spectrum X. Because of the MRM choice, because of the incredible technology risks that over the last 5 years that we did, and filed hundreds of patents, and we've licensed it to our partners so that we can all build them, now we're in a position to put silicon photonics with co-package options, no transceivers, fiber, direct fiber into our switches with a radix of 512. This is the 512 ports. This would just simply not be possible any other way. And so this now set us up to be able to scale up to these multi-100,000 GPUs.
Pusht gerne einmal die Däumchen nach oben für den Stream. Ja, wir sind fast an die 100 aktive Zuschauer. Die Däumchen können nach oben.
Data center,
für Jensen und für
we
mich.
could save tens of megawatts. Let's say 10 megawatts. Well, let's say 60 megawatts. 6 megawatts is 10 Rubin Ultra racks. 6 megawatts is 10 Rubin Ultra racks, right? And 60, that's a lot. 100 Rubin Ultra racks of power that we can now deploy into Rubins. All right, so this is our roadmap once a year, an architecture every 2 years, a new product line every single year, X factors up, and we try to take silicon risk or networking risk or system chassis risk in pieces so that we can move the industry forward as we pursue these incredible technology. Vera Rubin, and I really appreciate the grandkids for being here. This is our opportunity to recognize her and to honor her for the incredible work that she did. Our next generation will be named after Feynman.
Feynman. Oh, nice.
Okay, NVIDIA's roadmap. Let me talk to you about enterprise computing. This is really important. In order for us to bring AI to the world's enterprise, first we have to go to a different part of NVIDIA.
Oh, jetzt kommt die Umwelt.
Okay, in order for us to take AI to enterprise, take a step back for a second and remind yourself this. Remember, AI and machine learning has reinvented the entire computing stack. The processor is different, the operating system is different, the applications on top are different. The way the applications are different, the way you orchestrate it are different, and the way you run them are different. Let me give you one example. The way you access data will be fundamentally different than the past. Instead of retrieving precisely the data that you want and you read it to try to understand it, in the future, we will do what we do with Perplexity. Instead of doing retrieval that way, I'll just ask Perplexity what I want. Ask it a question, and it will tell you the answer. This is the way enterprise IT will work in the future as well. We'll have AI agents, which are part of our digital workforce. There's 1 billion knowledge workers in the world. There are probably going to be 10 billion digital workers working with us side by side. 100% of software engineers in the future, there are 30 million of them around the world, 100% of them are going to be AI assisted. I'm certain of that. 100% of NVIDIA software engineers will be AI assisted by the end of this year. And so AI agents will be everywhere. How they run, what enterprises run, and how we run it will be fundamentally different. And so we need a new line of computers. And this
Oh, Jensen. Ich bin noch da. Ist Jensen auch gleich wieder zurück? Also, an meiner Verbindung kann es nicht liegen. Der Stream ist noch da. Ich refreshe.
Will be fundamentally different. And so we need a new line of computers. And this
Oh, Tatsache, der Stream ist down. Alright, Leute. 50.000 aktive Zuschauer. Es droppt gerade hier bei Nvidia. Das heißt, die haben das 2-Stunden-Limit wahrscheinlich geknackt. Und hatten wahrscheinlich nicht genug Sendezeit. Also ja, jetzt werden Köpfe rollen. Ein löbliches Ende, denke ich, auch für meine Seite. Ja, freut euch auf das Video, was heute noch online kommt. Wie bereits gesagt, es wird sehr, sehr spannend. Ist auch schon hochgeladen. Ich muss nur noch das Thumbnail finalisieren. Aber vorher muss ich eine Kleinigkeit essen. Also, Leute, es war auf jeden Fall jetzt hier soweit ein sehr, sehr geiler Stream hier mit euch gemeinsam. Und Jensen, Huang, die GTC 2025. Auf jeden Fall ein spannendes Event gewesen. Einfach jedes Mal so die Entwicklung zu sehen auf industrieller Ebene ist schon wirklich ein Erlebnis für sich. Deswegen übertrage ich die GTC auch jedes Jahr aufs Neue, einfach weil es mich persönlich interessiert. Und die gesamte AI-Sparte, ich weiß, ist nicht jedermanns Sache, aber gerade jeder, der eine Nvidia-Karte zu Hause hat, ja, ist auch ein bisschen die Zukunft, ja, was prognostiziert wird. Wir haben jetzt hier tatsächlich in diesen Zyklus von Nvidia ein paar Einblicke gesehen und gezeigt bekommen, dass sozusagen nach Blackwell Ultra und Rubin Ultra und ja, dass immer in so kleinen Abständen so große Schritte gemacht werden, ist, denke ich, für uns alle ja ein interessanter Verlauf und wird dann auch sich dahingehend übertragen, ob wir dann auch wirklich ja jedes Jahr neue Grafikkarten sehen werden. Neben Refreshes ist natürlich dann auch die Frage, also bekommen wir dann nächstes Jahr schon vielleicht RTX 6000? Das wäre ein bisschen die Frage. Ich vermute eher nicht. Ja? Ich vermute, sie bleiben bei den ganz normalen Gaming-GPUs immer in diesem Clock-Cycle mit TikToks. Ja, also einmal eine Hauptarchitektur, dann einen Refresh und so weiter und so fort. Aber bis dahin, Leute, lasst dem Stream die Däumchen nach oben zurück und bis dahin Gaming Fitness, that's you see on Gax TV. Haut da rein und habt einen schönen Abend, Leute.